Alright guys, back with another resistance circuit. Okay, let's solve it. So, we have here this circuit. Let's get our equations. We gotta identify first, which is in series. Then we work from that. Okay, so we see here that remember, if it's series, there's a direct connection, which we see that in R2 Alright, pretty simple, right? So is right here. R23 is equal to R2 plus R3. Alright, now let's look at the other half of this whole part. Let's get we can see here that we can get R4 5. R4 5, they are in parallel. And if you get if you look at this R4 5 6, this shit is series with this shit because it's a direct connection, remember? And then R4 5 6, this whole shit is in parallel with this. And then once you have this, you need to add that to this. Why? Because there's a direct connection with R1 to this whole thing. Because it's in series. So, now we know that we just write our equations. If you want, here's the guide. Here's my guide. So, this is like just the formulas and stuff. Everything you need to know. These are examples or some stuff I made for understanding series and parallel. So let's get to it. Okay, R23 is equal to R2 plus R3. Let's get R4 5. R4 5 is equal to, remember the formula in parallel resistors, R4 plus the reciprocal of R5 and the reciprocal of those. Then remember what we talked about. R4 5 6 is equal to R4 5 plus R6 because they're in series. Alright, and then this whole thing, R4 5 6, is in parallel with this. Remember, it's in parallel because you go here. Oh, that ain't the direct connection. Because it can go here, it can go here. Something like that. You can mark the parallel nodes, you just go like this. If you see like that, it's parallel. Because you go here, you go here. Type shit. Okay, so, R2, 3, 4, 5, 6 is equal to 1 over R2, 3 plus 1 over R4, 5, 6 raised to negative 1. Okay. And remember, to get R total, it's just the sum of this and this. R1 and R2, 3, 5, 6. Okay, I am repeating myself, but yes, let's just solve. 6 plus R1. Okay, so like what I normally do, this is how I do it. I list down all of my equations because that makes it easier. So you don't have to keep going back to looking at the circuit. When you're solving, you're just looking at the equations, and I find that easier. But of course, it comes down to preference. You can watch lots of other videos online where they aren't listing down all the equations. They're just going it manually with the circuit. I just like looking at equations. So remember from my other videos. So our other value is current, of course, and what we do is we just get current in whatever it is, series or parallel. We use these as reference. We just get those. So I23 is equal to I2 equals I3. Again, we're just looking at this equation. We just follow off that. And remember, it's equal because current in series, they're equal to each other. you have I45, and that is equal to I4 plus I5. Current in parallel is just the summation. And we have I456 is equal to I45 equal to I6, because it's in series. And I2, 3, 4, 5, 6 equal to I2, 3 plus I4, 5, 6. And then our I total is equal to I2, 3, 4, 5, 6 is equal to I1. And then for our last value, voltage. So voltage in series is the summation. So V2 plus V3. V45 is equal to, so it's in parallel. When voltage is in parallel, they're equal. Why? Because if you're in parallel, you get the voltage directly from the source. I hope that's understandable. So V4 equals to V5. V456 is equal to, so series is, you add them, V45 plus V6. Actually, if you don't have to keep going back and like saying, looking if the equation is series or parallel. You just do the opposite of the current. You see this is summation, this is add. So for voltage equal, you see this equal. For voltage, you just add them. You can do like that. I just want to make sure that I'm correct. So V2, 3, 4, 5, 6 is equal to V2, 3 equal to V4, 5, 6, because it's in parallel, and you can see here that this is add. It's the opposite. And then our V total, which is given by the way, is V2, 3, 4, 5, 6 plus V1. Okay. Now, this is the fun part because we solve. Alright, so R23 R23, what is that equal to? R2 plus R3, 49 plus 51 ohms. That'll give you 100 ohms. Alright, so R4, and we have our next equation, R45 is equal to 1 over, what is our R4? Our R4 is 37 ohms plus what is this? What is R5? R5 is 45. And then we just put this into the calculator. Hold on. 1 over 37 plus 1 over 45 raised to and our answer is equal to 20.30 ohms. That's our R45. And then for R456 is equals to our R45, which is 20.30 ohms, plus, where is R6? R6 is 45 ohms. And this will give you 65.30 ohms. So next we have R23456, and R23456 is equal to 1 over 100 plus 1 over 65.30 raised to negative 1. Okay, so let's do that again. 1 over 100. By the way, there is another formula for parallel resistors, but that's not what we were taught, so. Because the formula is actually product over sum. I don't know if I should do that right now too. It's like, it will look like this. Product over sum, and that is also equal to the parallel circuits rather than this formula. Well, anyway, our answer is 39.50 ohms. Let me do this. Sorry for the sidetrack. Let me do this, just that you guys, just to make sure. Yeah, I'll give you the same answer, because they're all derived from each other and stuff like that. Okay. Sorry. So our total is equal to 39.50 ohms plus R1, and our R1 is 80. And that will give you 119.50 ohms. So that's our first value that we put now. 119.50 ohms. Okay, so what do you do next after this? If you watch my other videos, I gave this trick. If you have, in a column here on your table, if you have two values in a column already, you can get the third one for sure. Because the formula, I didn't write down the formula. V equals, that's terrible. V equals I, R. Alright, so we are looking for our current, so current total. Our current total will be equal to our V total over our R total. And so that is equal to, our V total is 220 over our R total, we just solved for that, 119.50 ohms. And this will give you 1.84 amperes. So the unit for the current is amperes. So let's write that. Alright, so once we've done that, what we're gonna do now is we just have to look at our equations, because remember we listed down our equations. Let's look. What can we get? So there are patterns, but what you want to do is you want to look at what you just solved for. Like, we just solved for our totals, right? So you go from your totals, of course, because that's our column with the complete values. So if you look here, it says our I total is equal to I23556 and I1. Oh, it's equal to I1 as well. So this is also equal to I1. And we can write that. Oh, what the hell? What the hell? Oh, wait, yeah, alright. So that is also your I1 at 1.84 amperes. And remember the trick I taught you. So V1 is equal to I1 R1, and that is equal to 1.84 amperes times our R1. R1 is 80. And our V1 will be 147 volts. 147.28 volts actually. 147.28 volts. So next, we're just gonna be looking at the equations again. So I don't know if you guys see it, but I see it. So remember, we're just looking at our equations, and I told you that the trick is to just keep building off from what you just solved for. And so it's a puzzle. It's a puzzle because you get one thing. Let's say you get one thing, it leads to another thing, leads to another thing. And I'll show you that right now. So you can solve this in two ways actually. Let me see here. Okay, what you want to do is you want to solve for 2, 3, 4, 5, 6. Why do we want to get 2, 3, 4, 5, 6? Whatever value for actually we want to get v2 3 4 5 6. My bad. Why do we want to get v2 3 4 5 6? You want to get v2 3 4 5 6 basically gives you v2 3 and v4 5 6. Okay, so where was I again? Okay, we can get our v2 3 4 5 6. So why do we need to get our v2 3 4 5 6? If we get our v2 3 4 5 6, we're given access to a lot of things. We can get v2 3 and v4 5 6. Why is that relevant? So this is all a puzzle, right? We have here our 2 3 values. It's like this. It's like the trick I showed you, but like this. So if you have 2 values, you can get the other one. So remember, we have this. Yes, we have our r, and we also have we're gonna solve for this. This is what we're gonna solve for. Remember, because v2 3 4 5 6 equal to v2 3. And if you get I2 3, I2 3, you can get I2 and I3, right? So, that's basically like the overall concept. Okay, so yeah, let's just solve for this. And you can also get the other values. I'll show you that later. Let me just... Alright, so you can get v2 3 4 5 6 in 2 ways. You can look at this equation, vt minus v1, or if you see this first, you can do it. I2 3 4 5 6 times R2 3 4 5 6. Because remember, we solved for this guy, and then I2 3 4 5 6. Remember, that's equal to IT and I1. So whichever you see first, but I think this is the, whatever you see first. But let's just do this one because I think that's what most people see first. So VT minus V1 is equal to V2 3 4 5 6. What is our VT? And that's 220. Yeah, remember. 220 minus our V1 is 147.28. Give me a calculator just to be sure. 147.28. 72 voltage. Voltage V23456, and this is also equal to your V23 and V456. So remember what I said earlier, we have our 2-3 values, and so we can get I23. So I23 is equal to V23 over R23, and our V23 is, we just solved for that, 7 plus 72, and our R23 is 100 ohms, and this will equate to 0.783, because remember, if you divide by 100, you just move the decimal points to the left. So 0.783 amperes. Yeah, and your I23, so this is also equal to your I2 and I3. So let's write that, 0.73 amperes, 0.73 amperes. And then remember what I said, the trick. So this is our voltage, so our V2 is equal to I2 R2, our V3 is equal to I3 R3. So you got 0.783. What is our R2? Our R2 is 49. What is our R3? Is 51. Let's solve for them. So 49 times 0.73, that'll give you 35.77 voltage. And then for our V3, that will give you 37.23 voltage. So yeah. Now what do we do next? So remember, we also have our 4, 5, 6 values. So let's do that. We get I456. Similar process. I456 is equal to V456 over R456, and this is equal to, what is our V456? Our V456, what was it again? I forgot. Oh, it's right here. 72.72. What is our R456? We solved that earlier, 65.30 ohms. So let's just do that. I mean, a little bit of a tedious process, but it's alright. And I'll give you 1.11 amperes. And our I456, as our equations, is equal to I45 equals to I6. Since it's also equal to I6, please do 1.11 amperes. And so this is very important. We have our I45. And if we have an I45, you already know that we have your resistance value. We have R45. We can get V45. And V45 is equal to V4 equals to V5. Bada boom, bada bing. And then, so yeah, let's just solve for that. You know, V45 is equal to, let me write it down, R45. And this is equal to, remember we just solved for I45, so 1.11 times R45, we solved for that, 20.30. So this is also why it's very good to list your values down, because you keep going back to it. 20.3. And this is equal to 22.61 voltage. And this is also equal to your V4 equals to V5. And then what else can we do? Then, you know, these are pretty simple already. Just remember, this is I4 equals to V4 equals to R4. Then we also have our I5 is equal to V5 over R5. We also have our V6. V6 is equal to I6 R6. So we can just do all of these. What is our V4? It is 22.61 over our R4, which is 37, and this will give you 1 divided by 37.61 amperes. Alright, and then this one is 45. Oh wait, no, I mean 22.61 over 45 is 0.50 amperes. Alright, 0.50 amperes. And then for our V6, which is 1.11 times our R6, which is 75. 83.2 25 voltage. Okay, so yeah, that is pretty much it. You wanna like just try to double check your answer. By the way, if you double check your answer, it won't be exact values, and they aren't foolproof. Honestly, like you really like understand the how the circuit flows. But if you're just looking at the equations, you're not able to like, like you really have to see if you interpreted the diagram correctly. So, but let's try to see. So, you look at your voltage values. Vt is equal to V23456 plus V1, and remember your so let's just try to see that. What is our V1? Our V1 is 147.28, and our V23456 equal to 72.72, and then so 72.72 plus 1 plus this, obviously, because that's how we solved it. But you can also look at this, so we can like try to expand V23456. So remember, it's also equal to your V23. So your V23 is V2 plus V3, and your V2 plus V3, this looks like 72 to me. So yeah, if you want to double check your answers, well, you can look at your equations, but you look at which is in series. Which voltages is in series. So we have this one, and you add them to this one, which is because like, if they're in series, you can like try to see if they'll match up with the total voltage. And you can do the same with like your current. Let's say so let's say like I2 plus I6. What is I2 plus I6? 35.77 plus 83.2. And that should equate to, wait, why am I looking there? I mean I2 plus I6. And that should equate to your total current. So yeah, that's it. I mean, it was pretty long, but yeah, I just wanted to explain everything while using the calculator, because my other videos, like I already had the answers there. So yeah, alright, goodbye. This shit's fine. Voltage. Alright, bye bye.